Hello everyone and welcome back to Dr. Shaurav's classes. Today we are solving a very important conceptual question from RCC, and this is the type of question that checks whether you truly understand the limit state design or you are just memorizing the formulas. So let's read the question very carefully. For a singly reinforced rectangular reinforced concrete beam, the following data are given. XU limit by D is 0.456, FCK is 15 N per meter square, and effective depth D is 550 mm, and the actual neutral axis depth XU, that is 300 mm. And we are asked what is the type of failure of the section. Options are: option A is tension failure, option B is compression failure, option C is ductile failure, and option D is bond failure. Now listen, this is a pure concept based question. If your concept is strong, you can solve it in less than a minute. But today we are going to solve it very deeply and understand everything very properly. Now first, let's recall the theory. In a singly reinforced beam, failure depends on the position of the neutral axis, and there are three important cases. First is the under reinforced section, second is the balanced section, and third is the over reinforced section. Okay, and everything depends on the comparison between the actual neutral axis depth, that is XU, and the limiting neutral axis depth, that is XU limit. Okay, now let's understand what limiting neutral axis depth means. The limiting neutral axis depth is the maximum neutral axis depth at which the concrete reaches its ultimate strain, that is 0.0035, and still just yields simultaneously. So this is the balanced condition. If steel yields first, we get the ductile failure, and if concrete crushes first, we get the brittle compression failure. Now we are given that XU limit by D is what? 0.456. Now this ratio depends on the grade of steel. For Fe500 steel, it is 0.46 approximately. So clearly this beam is designed with a high strength steel. Now effective depth D is 550. So let's calculate limiting the neutral axis depth. So XU limit 0.456 into D. Okay, now substitute. XU limit is 0.456 into 550. Now multiply very carefully. First multiply 456 into 55. So 456 into 50 is 22800. 456 into 5 is 2280, and total will be what? Total will be 25080. Okay, now divide by 100. So we get XU limit is 250.8. Okay, so limiting neutral axis depth is 250.8. Now the question gives actual neutral axis depth. So XU is 300. Now compare the two values very carefully. Actual neutral axis depth is 300 and limiting neutral axis depth is 250.8. Now clearly XU is greater than XU limit. Okay, so this is most important step. Now what does this physically mean? If actual neutral axis is deeper than limiting neutral axis, it means there is more steel than required for the balanced condition, and that means section is over reinforced. Okay, now what happens in the over reinforced section? Let's understand the behavior. In over reinforced beam, the steel percentage is high. Steel does not yield before the concrete crushes. Concrete reaches ultimate strain first and crushing of concrete happens suddenly. And this type of failure is brittle. And the brittle failure is very dangerous because no warning, no large deflection and sudden collapse. So we always avoid the over reinforced sections in design. Now let's connect this to the options. So the options are, option number A is the tension failure. Tension failure occurs when steel yields first. That happens in the under reinforced sections, but here XU is greater than XU limit. So not the tension failure. Now come to option number B, the compression failure. Compression failure occurs when concrete crushes first. That happens in the over reinforced section. This matches our case. Now come to option C, ductile failure. Ductile failure means large deformation before collapse. That occurs in the under reinforced sections. Not our case. Now option D, bond failure. Bond failure is related to slip between the steel and concrete. Nothing in question suggests bond use. So correct answer is option number B is the compression failure. Now let's summarize this conceptually. Step number 1. Calculate limiting neutral axis depth. Step number 2. Compare with the actual neutral axis depth. Step 3. Decide the type of reinforcement. And step number 4. Identify the type of failure. Okay. So whenever you see a question about the failure in the type in RCC, never start with the stress block formulas. Immediately check is XU less than or equal to or greater than XU limit. That comparison alone gives the answer. And this is the total solution for this question. I hope this is clear to you. If you have any kind of doubt regarding this question, you can ask me in the comment section. So see you in the next video with a new question. Till then, keep learning, keep growing with only Dr. Shoros's classes. Bye bye.